Hello, welcome once again to ASM Chicks online maths class. This morning we want to discuss a very interesting topic in mathematics known as matrices. The singular is matrix. So the singular of the word matrices is just matrix. So don't be confused when you see this word. They still mean the same thing. So this is singular while this is plural. Kindly hit the red button to subscribe to my channel. It gives you notification whenever a new video is out. So now when you talk about the word matrix, what comes to your mind? Matrix is just a rectangular arrangement of numbers in rows and columns. A rectangular array of numbers in rows and columns. Take for example, when you write a test, let's say the teacher records the scores and maybe the number of students that obtains a particular scores in a test. You shall see that if the score is over 5, maybe a student got 1, you have 2, you have 3. Out of this test of 5 marks, the lowest score was 2, while the highest score obtained by the students in a particular class is just 3. Now this teacher found out that 8 persons scored 1, 3 persons scored 2 marks, and let's say 9 persons scored 3 marks. The teacher has now arranged these numbers in rows and in columns. So when you talk about the horizontal direction, it's a row, okay? But the vertical direction is a column. So you see that this has 2 rows, 1 and the 2, while it has 3 columns, 1, 2 and 3. Alright, so this kind of arrangement is still matrix because these numbers are arranged in rows and columns. Okay, so that is what we mean by a matrix. A matrix is a rectangular arrangement of numbers in rows and columns. And having known the meaning of a matrix, let us see the types of matrices we have. Number 1 is a row matrix. By now you've known that a matrix is just arrangement of numbers in rows and columns, and a row is just the arrangement in the horizontal platform. So now I'm talking about a row matrix. Simply put, a row matrix is just a matrix that has only one row. For example, if you have a matrix like this, 1, 2, 3, you can see that this matrix has only one row. So this kind of matrix is called a row matrix because the row is just one. Okay, it can still be like this. This is also a row matrix. It still has one row. This is even still a row somehow. Okay, so a row matrix is a matrix having only one row. Okay, so now apart from this row matrix, there is another kind of matrix known as the column matrix. If you know row matrix, automatically you've known the meaning of a column matrix. A row matrix is just with a matrix with a row, while a column matrix should be a matrix with just a column. It will not appear in this form. Let's say 1, 2, 3. Look at this number, it has just one column. So it's a column matrix. Okay, it can still be like this. This is still a column matrix because it has one column. So whenever you come into a matrix and you find out that it is having just one column, the matrix is tagged a column matrix. So we've discussed the row matrix and the column matrix. What about the square matrix? Now a square matrix is a matrix that you see and the rows and the columns are equal. Normally your idea of square from your plane shapes will tell you that a square is a plane shape or quadrilateral with 4 equal sides. Then coming to matrix, when you have a matrix tagged square matrix, it means it's a matrix in which all the rows and the columns are equal. For example, 1, 2, 3, 4. This column has 2 rows. Look at it. 1, 2. The rows are 2. It also has 2 columns, 1 and 2. So you've seen that the number of rows is equal to the number of columns. Therefore, it is a square matrix. But this kind of square matrix is a 2 by 2 square matrix because the row is 2 and the column is also 2. So let's see, we can still have the 4 by 4 or 3 by 3 square matrix. Let's say 1, 4, 5, 9, 2, 1, 0, 1, 4. Let's say 4. Okay. If you take a look at this matrix, you see that the rows are 1, 2, 3. So it has 3 rows. How many columns? 1, 2, 3. It has 3 columns. So you can now see that in this matrix, the rows are equal in number with the columns. Hence, it is a 3 by 3 square matrix. Okay, so the key point here is for you to note down that whenever you talk about a square matrix, it is just a matrix having equal rows and column, be it 2 by 2, 3 by 3, 4 by 4, as the case may be. So we've successfully discussed the square matrix. We still have the identity matrix. Okay, now in mathematics, you know that the identity of multiplication is just 1, because any number multiplied by 1 gives you the same thing. So 1 is a very nice element in the sense that it does not have any impact on any number it is being operated to. Okay, so 1 does not have any impact on numbers under multiplication. 9 times 1 is 9, 3 times 1 is 3, 7 times 1 is 7, etc. So that's why 1 is known as the identity of multiplication. Also, when you come to matrix, there is a matrix called the identity matrix. Such matrix does not have any impact on other matrices when it multiplies them. When we get into the multiplication of matrix, you understand what I'm talking about here better. So this identity matrix looks like this. You can have 1, 0, 0, 1. This is how it looks like. This one is 2 by 2. Identity matrix. It is a square matrix. You can have 1, 0, 0, 0, 1, 0, 0, 0, 1. You see what is happening? This is called the diagonals. The leading diagonals. You can see them. This is still the diagonal. So the diagonal of this matrix is 1, while every other element there is 0. So once you see this kind of matrix, just know that this matrix is talking about the identity matrix. Okay? There are several types of matrices, not only this, but for this lesson we take this. We still have the singular and non-singular matrix. We have the diagonal matrix, etc. There are a lot of them. But today, let's just concentrate on these 4 types of matrices. Now, having known the meaning of a matrix, let us go into the operations in matrix. The operations in matrix. The operations in matrix, we have the addition, subtraction, we have the multiplication, we have inverse. We saw so many things under the operation of matrix. So let's take the addition and subtraction of matrix. So addition and subtraction of matrices. Okay, for example, somebody can tell you that given that matrix A equals, let's say 1, 2, 3, 4, B equals minus 1, 4, 0, 2. So you can be asked to find number A plus B, C, A minus B, D, oh, this is B, C, B minus A. Okay, so let's see this. Solution. For number A, here we have A plus B. The matrix A is 1, 2, 3, 4. 1, 2, 3, 4. Plus the matrix B, which is minus 1, 4, 0, and 2. Now look at the way you add. You add the first and the first, second and the second under the first row. Come to the second row, do the same thing, first and first, second and second. That's how to add. So here I'll have 1 plus negative 1. I'll give a space. 2 plus 4. You come down. 3 plus 0. You shift again. 4 plus 2. Okay? Now you sum up. 1 minus 1 is 0. 2 plus 4 will give us 6. 3 plus 0 is 3. And 4 plus 2 will give us 6. So you see that the sum of the matrix A and B will give us 0, 3, 6. Now let's take the second one where we have a minus b. A minus b, my a is 1, 2, 3, 4. Minus b, b is minus 1, 4, 0 and 2. Okay, the same process is involved under subtraction and addition, so there is no difference at all. You still take the same procedure. So you see, say 1 minus, I have negative 1 here, I'll give a space, I have 2 minus 4, you come down, 3 minus 0, then 4 minus 2. Look at what I'm doing here. First and first, second and second, third and third, fourth and fourth. Okay? So now, if we take this subtraction, we shall get, you know, minus minus turns to plus. So when you have 1 plus 1, this will give us 2. 2 minus 4 will give us minus 2. 3 minus 0 is still 3. And 4 minus 6 is 2. It's 2. 4 minus 6 will give us 2. Okay, so that's how to get the subtraction. We still have the third question where we'll have b minus a. B minus a, that's the next thing we need to get. Okay, b minus a, that is for number c. B minus a. This time around means that b must come first. That's the implication. So b is now minus 1, 4, 0 and 2. Minusing a, which is 1, 2, 3, 4. As usual, you have the first minus first, second minus second, first minus first, second minus second. Okay? So this is equivalent to minus 1 will give us minus 2. 4 minus 2 is 2. 0 minus 3 is minus 3. And 2 minus 4 is minus 2. If you take a clear look here, you see that these and these are almost the same thing, apart from their signs are not the same thing. Okay? So wherever I have negative, I have positive. Negative, positive, positive, negative, negative, positive. So that's why, because one is minus and one is plus. This will tell you that subtraction in multiplication is not commutative, in the sense that when the arrangement is changed from A to B into B to A, we got different values. But if we do this for addition, we still get the same value. We call this commutativity. Whenever A star B equals B star A, not because this star is an operation. Let's say it's a binary operation, star, which can be plus, minus, times any operation you're talking about. So whenever the arrangement does not matter and these are equal, we say that that value, that operation is commutative. So commutative is seen in addition and multiplication, but you cannot see that in division and subtraction. Because 1 plus 2 is the same thing as 2 plus 1. They will all give us 3. But when you have 1 minus 2, is it the same thing with 2 minus 1? It's not the same thing. Because 1 minus 2 is minus 1, and minus 1 is not equal to 1. 2 minus 1 is 1. That is why we see that we got different values when we try to get A minus B and B minus A. So you've now seen how to add and subtract matrix. Whether the matrix is bigger than the size we used here, you know, we used 2 by 3, okay? We still got, even if you are doing 3 by 3 or 4 by 4, no matter the kind of matrix you will have to add, you still take the same procedure in doing that, okay? So now, let's go into multiplication of matrix. Multiplication of matrix. So you've seen how to add matrix. So let's see the multiplication of matrix. Let's say if you have A equals 0, 1, 5, 2 and B equals 2, 4, 1, 8, for instance, and you're asked to find AB. To find AB means they want us to multiply the matrix A by the matrix B. So it's quite simple to solve. To do that, AB equals, A is coming first, 0, 5, 1, 2, multiplying matrix B, which is 2, 4, 1, 8. Okay? This multiplication is not difficult, but if you want to understand it appropriately, there is what I want you to be doing for me. Okay? Always know that the row is multiplying the columns. This is the row. The row will multiply the column. Okay? And this is the first, this is the second. Let me call this 1, this number here 1, and call this 2. Now, for the row, for the column, the first one here is 1. Why this one here is 2? Okay, the idea in this multiplication is that the first will multiply first, plus second will multiply second. So what I will write here is just first multiplying first, which is 0 times 2 plus 1 times 1. 1 times 1. I'll give a space. The same thing I do to this one, I'll still do it here. This is first, this is second. Okay? I will still say first times first plus second times second. I'll have first as 0 times 4 plus second 1 times 8. 1 times 8. Okay? You come down. When you come to the second row, I will take this number here as my first and take this one here as my second. It will still do the same thing to these columns. So I have here as 1, I have here as 2. So I'll still have 5 times 2 plus 2 times 1. First times first plus second times second. So I have 5 times 2 plus 2 times 1. I'll give a space. I'll do the same thing to these numbers here, 4 and 8. So I have 5 times 4. 5 times 4 plus 2 times 8. 2 times 8. Okay? And having done that, you just simplify further to get your answer. So my AB equals, we have 0 times 2 is 0 plus 1 times 1 is 1. 5 times 2 is 10. 2 times 1 is 2. 0 times 4 is 0 plus 1 times 8 is 8. Okay. 5 times 4 is 20 plus 2 times 8 is 16. Alright, so this sums up to 0 plus 1 is 1. 0 plus 8 is 8. 10 plus 2 is 12. And 20 plus 16 will give us 36. So the product of this matrix A and this matrix B will still give us 1, 8, 12, and 36. So this is the multiplication of 2 by 2 matrix. You can still multiply 3 by 3 matrix. It's not difficult. It's still the same process. Let's see. Okay, let's see how we can multiply 3 by 3 matrix together. So multiplication of 3 by 3 matrices. Multiplication of 3 by 3 matrices. Okay, so let's see how this can be done. For example, if A equals 1, 2, 3, 4, 5, 6, 7, 8, and 9, and B equals let's say 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, so if you're asked to find AB, let us see how this can be done. You're asked to find AB. Okay, now look at what you do here. AB is equivalent to the product of the two matrices we have in there. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Multiplying 1, 0, 0, 0, 1, 0, 0, 0, 1. Let us see how this can be done. So this AB equals So now see how to do this so you won't get confused along the line. This is the first, second, third for the row. Then the column, this is first, second, and the third. The idea is that first row multiplies first column, second element in the first row, see multiply second element in the first column, third element in the first column multiply the third element in the first column, third element in the first row multiplies third element in the third column. So we have first times first, 1 times 1 plus second times second, 2 times 0, okay, plus third times third, 3 times 0. You give a space, do the same thing here. You have 1 times 0 plus 2 times 1 plus 3 times 0, okay? So it's first times first plus second times second plus third times third. Do the same thing here. First times first plus second times second plus third times third. Do the same thing in the third column. First times first plus second times second plus third times third. So you come down and continue. Use the same second column to do whatever you've used the first column to do, the first row to do. I'm using the first second column now to perform the same operation I used the first column to perform. So first times first, 4 times 1 plus 4 times plus 5 times 0 plus 6 times 0 also. I'll give a space, I'll do the same thing here. 4 times 0 plus 5 times 1 plus 6 times 0. You give a space, do the same thing here. You have 4 times 0 plus 5 times 0 plus 6 times 1. We come to the last row here. Do something using 7. 7 times 1 plus 8 times 0 plus 9 times 0. Second column, 7 times 0 plus 8 times 1 plus 9 times 0. You give a space, do the same thing down here. You have 7 times 0 plus 8 times 0 plus 9 times 1. So you see how we got all these numbers. Then at the end of the day, you have to add up. 1 times 1 is 1, plus 2 times 0 is 0, 3 times 0 is 0. 4 times 1 is 4, plus 5 times 0 is 0, plus 6 times 0 is still 0. 7 times 1 is 7, plus 8 times 0 is 0, plus 9 times 0 is 0. You give a space. 1 times 0 is 0, plus 2 times 1 is 2, plus 3 times 0 is 0. 4 times 0 is 0, plus 5 times 1 is 5, plus 6 times 0 is 0. 7 times 0 is 0, plus 8 times 1 is 8, plus 9 times 0 is 0. You come to this side. 1 times 0 is 0, plus 2 times 0 is 0, plus 3 times 1 is 3. 4 times 0 is 0, plus 5 times 0 is 0, plus 6 times 1 is 6. 7 times 0 is 0, plus 8 times 0 is 0, plus 9 times 1 is 9. So at the end of the day, you've got to sum up to get your answer. This is 1, this is 4, because 0 is nothing. This is 7, this is 2, this is 5, this is 8, this is 3, this is 6, and this is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You saw here that we got the same answer as the question is, right? The reason is because we use an identity matrix to multiply the matrix, and like I told you, identity matrix is a matrix that has no impact when it is operated on other matrices. Their identity, they don't have any impact on others. Just like in your mathematics, 8 times 1 is 8, 9 times 1 is 9. the element 1 is the identity of multiplication. It has no impact on other elements. Okay, so at this point in time, we should switch into what we call the determinant of a 3 by 3 method. Determinant of a matrix. So given matrix A as a 4, 5, 6, 8, find that A. So we are given the matrix A equals 4, 5, 6, 8, and we are asked to find that A. That A means determinant of A. So if you don't write it in full, they are free to say that A. It is still talking about the determinant of A. Look at another way determinant can be written. This modulo symbol, if you see this in matrix, know that they are talking about determinant of A. If it is B that is inside, they are talking about determinant of B. So determinant of this 2 by 2 matrix is just the cross multiplication, the difference between the leading diagonal and the product of the elements in the leading diagonal and the product of the elements in the other diagonal, non-leading diagonal. Okay, so look at what we just do. Put two brackets, just cross multiply. 8 times 4, 6 times 5. You are subtracting, just cross multiplication. 8 times 4 and 6 times 5. So 8 times 4 is 32, 6 times 5 is 30, and when you subtract you get 2. So therefore, that A equals 2. So that's how to get the determinant of 2 by 2 matrix. It's not difficult. Cross multiplication. 8 times 4 minus 6 times 5. 8 times 4 is 32 minus 6 times 5 will give us 30. And when you take this difference, you are getting 2. So this is how to get the determinant of a 2 by 2 matrix. So they can still ask you to get determinant of a 3 by 3 matrix. That is where we have a more work to do. So to get the determinant of a 3 by 3 matrix, you have to do something to that matrix to get a 2 by 2 matrix. Okay, now we want to discuss the determinant of a 3 by 3 matrix. Okay, so let's take this example. Given that A equals let's say 1, 2, 3, 4, 5, 6, 7, 8, and 9, then we should find the determinant of A. And to get the determinant of a 3 by 3 matrix, which is quite different from the approach we take in getting the determinant of a 2 by 2 matrix, we have to split this into 3 2 by 2 matrices for it to be able to be done. So you always call the first element here plus, this is minus, this is plus. Okay, so you now have it as taking the first element 1, it multiplies the minus. What do you mean by the minus? The minus are the elements we get when we cancel the elements in the same row and in the same column with this element 1. So when we cancel it, we get 5, 6, 8, and 9. 5, 6, 8, 9. Then minus 2 into, okay, so if I'm taking minus 2 now, I will cancel the same row with minus 2 and the same column with it. I have 4, 6, 7, and 9. 4, 6, 7, and 9. Okay, then plus 3. I'll have, if I cancel the elements in the same column and the same row with 3, I'll have 4, 5, 7, and 8. 4, 5, 7, and 8. Now we can comfortably find the determinant of these 2 by 2 matrices as usual. So this gives us that determinant of A equals 1. 9 times 5 is 45 minus 8 times 9 is 48, then minus 2. 9 times 4 is 36 minus 7 times 6 is 42. Okay, plus 3 into 8 times 4 is 32 minus 7 times 5 is 35. Okay, the determinant of A is now 1 into 45 minus 48 is just minus 3 minus 2 into 36 minus 42 will give us minus 6 plus 3 into 32 minus 35 is minus 3. Now when you open the brackets, you have 1 times minus 3 is minus 3, negative 2 times negative 6 is plus 12, 3 times minus 3 is minus 9. So finally we find out that minus 3 plus 12 is 9, and 9 minus 9 will give us 0. So whenever the determinant of any matrix is 0, it means that the matrix is either a singular or non-singular. I will tell you in the next episode, because the determinant of a matrix, when it is 0, it is called something, which is because we didn't discuss 2 other types of matrices, which are the singular and the non-singular matrix. Okay, alright, so kindly hit the red button to subscribe to my channel. It gives you notification whenever a new video is out. Thank you for watching. The transpose of a matrix is just the interchangement of the rows and columns of that matrix. Whenever you make the row of a matrix to become the column and the column to become the row, you've just transposed that matrix. Okay, so just know that the transpose of a matrix is just the interchangement of the rows and the columns of the matrix. Alright, okay, for example now, given that A equals 1, 4, 5, 6, find trans A. When you see trans A, know that they're asking you to get the transpose of A. So now A transpose, or rather trans A, is something. Trans A will give us, make the row to become the column. This is the row, 1, 4 is the first row. So I will bend it to have 1, 4. Okay? I have made this row 1, 4 to become the column. 5, 6, which is just the row, I will still make it to become the column. So look at what I'm having. This is just the transpose of this matrix, because I've made the row to become the column and the column to become the row. That's the transpose for you. So if you have again, given that C equals 1, 2, 3, 4, 5, 6, 7, 8, 9. So find C transpose. Okay, if you have the matrix C here, and we ask to find the transpose of the matrix C, so trans C will be just equals to making the row. Look at the first row, 1, 2, 3. I'll make it to be the first column, 1, 2, 3. Okay, look at the second row, 4, 5, 6. I will make it to be the column 4, 5, 6. Alright, now look at the last row, 7, 8, 9. I will make it to be the column 7, 8, 9.